This is linear systems B. This is the back of the first page. Linear systems B, this is question number 1. We have 2B plus 2Z equals 14 and 6B equals 18. Okay, so we're going to start with a second equation because we can solve this. If 6B equals 18, well, 6 times what equals 18? 6 times, well, of course, let's see. In order to get rid of a times, in order to undo multiplication, we do the opposite. We divide. We're going to divide this side by 6 to get rid of that times 6. And if we divide this side by 6, in order to keep this thing equal, we've also got to divide this side by 6. Okay, so B times 6 divided by 6, they cancel out. Any number times 6 divided by 6, you get back to the original number. So I have B equals 18 divided by 6. 18 divided by 6 is 3. So B equals 3. Now let's make sure that works. 6 times 3 equals 18. Yeah, it does. 6 times 3 is 18. So B does equal 3. Okay, so I've got one of my variables solved for. For each of these problems, you're going to solve for 2 variables. Okay, so I've got B solved for. B equals 3. Now, I'm going to substitute. I'm going to rewrite this original top problem, only instead of B, I'm going to write what B equals. In this case, B equals 3. So I'm rewriting my original problem, only instead of a B, I'm putting what B equals. B equals 3. So 2B, instead of B I have 3, plus 2Z, I'm going to leave Z as Z for right now, equals 14. Okay? So let's simplify this. 2 times 3 is 6. So I have 6 plus 2Z equals 14. Okay, so 6 plus 2 times something equals 14. Well, let's get rid of this 6. Okay, now this is a positive 6. So in order to get rid of a positive 6, we can add a negative 6, or we can just subtract 6. So 2Z plus 6 minus 6. The thing is, if I subtract 6 from this side, in order to keep this thing equal, I've also got to subtract 6 from this side. Okay, so I've got 2Z plus 6 minus 6. Any number plus 6 minus 6 cancels out. So I've got 2Z equals 14 minus 6. 14 minus 6 is 8. So I have 2Z equals 8. 2Z equals 8. So 2 times something equals 8. 2 times what equals 8? Well, I divide this side by 2. Divide this side by 2. I get Z equals 8 divided by 2. Z, 8 divided by 2 is 4. So Z equals 4. Z equals 4. B equals 3. Now let's make sure this thing works. So I'm going to go back to my top equation. I know B is right because 6 times 3 does equal 18. That checked. So I'm going to go back and I'm going to substitute. For B, I'm going to substitute 3 because that's what B equals. And for Z, I'm going to substitute what Z equals. In this case, I'm saying Z equals 4. So I'm going to substitute 4. Okay, so I'm going to make sure this works. So 2 times 3, that gives me 6. 6 plus 2 times 4 is 8. 6 plus 8 equals 14. Let's see, 8 plus 3. Yeah, it works. Check. So Z equals 4. B equals 3. Questions on number 1? Great. Let's look at number 2. This is the linear systems B. This is the back of the first page. So, I got 5A equals 15, and I want to know, and I know 2 times A plus 3 times C equals 9. So, first thing I'm going to solve for here is A. If 5 times what equals 15? Well, I know divide by 5, times 5 divided by 5, they cancel out. I get A equals 15 divided by 5. 15 divided by 5 is 3. Cover your mouth when you cough. A equals 3. So I'm going to make sure this works. 5 times 3 equals 15. Yeah, that works. So A does equal 3. So I've got half my equation, I got half my answer. Now I want to know what C equals. So I'm going to rewrite this original problem, only instead of A, I'm going to substitute what A equals. So I'm going to substitute 3. 2 times 3 plus 3 times C equals 9. Okay, 2 times 3 is 6. So 6 plus 3 times C equals 9. 6 plus 3C equals 9. Go to another place. 6 plus 3C equals 9. Alright, I want to get rid of this 6. This is a positive 6. So I'm either going to add a negative 6 or just subtract 6. Anything plus 6 minus 6, they cancel out. But if I subtract 6 from this side of the equation, in order to keep this thing equal, I've also got to subtract 6 from this side of the equation. So I got 3C equals 9 minus 6. 9 minus 6 is 3. So 3 times something equals 3. Well, in that case, C must equal, divide by 3, divide by 3. 3 divided by 3 is 1. C equals 1. Now I'm going to go back to my original problem. So A equals 3, C equals 1. And I'm going to make sure this thing works. So instead of A, I'm going to substitute what A equals. I'm going to substitute 3. And instead of C, I'm going to substitute what C equals. C equals 1. And I'm going to make sure this is true. 2 times 3 is 6. 6 plus 3 times 1 is 3. 6 plus 3 equals 9. Yes, it does. Yes, that's true. It checks. Questions on number 2. Yes?
Questions on number 2.
Number 3. 5C equals 20. 5C plus 3V equals 36. All right, let's figure out what C equals. Well, 5 times what equals 20? C must equal 5 times 4 equals 20. Or if I divide this side by 5, divide this side by 5, 20 divided by 5 is 4. So C equals 4. 5 times 4 equals 20. Yes, this checks. C definitely equals 4. Now I'm going to go to this problem, and instead of C, I'm going to substitute what C equals. So I'm going to substitute 4 instead of C. And then I've got to rewrite the rest of it. So this is just my original problem up here, only instead of C, I substituted what C equals. I substituted a 4 for C. Now I've got 6 times 4, that gives me 24 plus 3V equals 36. 24 plus 3V, 24 plus 3V equals 36. Alright, in order to get rid of this plus 24, I've got to subtract 24. If I subtract 24 from this side of the equation, I've also got to subtract 24 from this side of the equation to keep this thing equal. Okay, so 24, 3V plus 24 minus 24, they cancel out. So I've got 3V on my left, and on my right, I've got 36 minus 24. 36 minus 24 is 12. So 3V equals 12. In order to get rid of this times 3, I'm going to divide by 3. If I divide this side by 3, I've got to divide this side by 3. Times 3 divided by 3, they cancel out. V equals 12 divided by 3. 12 divided by 3 is 4. So V equals 4. Now I'm going to go back to my original problem. V equals C equals 4. V equals 4. C equals V. Okay, let's make sure this works. So instead of this C, I'm going to substitute what C equals. I'm going to substitute a 4. And instead of a V, I'm going to substitute what V equals. V also equals 4. Let's see if this works. So, 6 times 4 is 24. 24 plus 3 times 4 is 12. 24 plus 12 equals 36. Yeah, it does. 24 plus 12 is 36. So this works. C equals 4 and V equals 4. Questions on that one? Last one. Alright, 6C equals 18. C plus 2Y equals 11. I want to find out what C equals. 6 times what equals 18? C must equal 3. 6 times 3 equals 18? Yeah, it does. It checks. C is definitely 3. Okay, so I'm going to rewrite my original problem up here, my top equation, only instead of a C, I'm going to substitute what C equals. So I'm going to write 3, instead of a C, I put 3 because C equals 3. 3 plus 2y equals 11. Okay, so I know to get rid of this plus 3, I've got to subtract 3. If I subtract 3 from this side, I've also got to subtract 3 from this side to keep this thing equal. Okay, so 2y plus 3 minus 3, they cancel out. I've got 2y equals 11 minus 3. 11 minus 3 is 8. Okay, great. So 2y equals 8. 2 times what equals 8? Well, y must equal 4. 2 times 4 equals 8. So y equals 4, c equals 3. Let's go back to our original problem and make sure this thing works. Instead of a c, I'm going to substitute what c equals. I'm going to substitute a 3. And instead of y, I'm going to substitute what y equals. Y equals 4. Okay, so 2 times 4 is 8. 8 plus 3 equals 11. Is that true? Yeah, that works. Oh, whoops. So c equals 3, y equals 4. Questions on that?